Good morning, Math 2. This week we're going to build a little bit off of what we did last week. Where last week we talked about trig ratios, the sine, cosine, and tangent, and how we can use the angles to relate to the side lengths. And we also figured out how to find a missing side length when given the angle on one other side. But this week I want to figure out what happens if I have a right triangle. I'm given two sides, and I need to find a missing angle. Now that is when I'm going to use something called inverse trigonometry. And when I think about inverse, I just want to think about inverse as undoing. So if we look down at the next slide, this says use inverse sine, inverse cosine, and inverse tangent. And I'll write the inverse tangent so that you remember that I read that as inverse tangent. And I'm going to find a missing angle. Now, if I look at this triangle that I have sitting here, I've labeled an angle theta. I'm going to pretend that that's where my little guy is standing at. Now, I know that the side length 13 is my hypotenuse. The unlabeled side, which is over to the other side of the triangle, is the opposite leg. And my 10 is my adjacent. Now, since I know the hypotenuse and the adjacent, I'm going to say, oh, that's the cosine, because the cosine of an angle theta equals the adjacent leg divided by the hypotenuse, which in my case is 10 divided by 13. But there's a problem. I want to get rid of the cosine because I want my answer to just say, hey, theta is approximately some number. So instead of saying that the cosine of theta equals 10/13, I'm going to say that theta equals the inverse cosine of 10/13. Now what's really happening, and this part you don't have to write down, is since we have cosine of theta equals 10/13, I want to get rid of my operation cosine. And it's kind of like, oh, the opposite of addition is subtraction. The opposite of multiplication is division. The opposite of squaring is square rooting. The inverse of cosine, or the opposite function of cosine, is inverse cosine. Then my cosine and cosine inverse undo each other. And we're left with theta equals the inverse cosine of 10/13. So now all that's left for me to do is to punch that up in a calculator. And I'm going to pay a lot of attention to that reminder sitting at the bottom of this box, which says that I need to be sure my calculator mode is set to degrees. And like we talked about last week, degrees are a really important thing. Next year in Math 3, you'll talk about radians. So I type in inverse cosine of 10/13. And I get my answer of 39.715 degrees. Yes, you need to include the units. Yes, we need to go out to 3 decimal places. If you're ready, let's go on to example 2. If not, go ahead and pause and rewatch this part first. Part 2, we're given another triangle. And I can see my angle theta. And I'm working with a right triangle. So I can use sine, cosine, and tangent. I know that the longest side opposite the 90-degree angle is my hypotenuse. The side opposite my angle theta is my opposite side. And the leg directly next to the angle is my adjacent side. I'm working with opposite and adjacent, that's what I've been given, and we're trying to find the angle theta. Well, opposite and adjacent, if I take the opposite leg divided by the adjacent leg, that's the tangent of my angle theta. So I'm going to say the tangent of theta equals my fraction 8/5. Now, since I want to solve for theta, I'm going to use inverse trig and say that theta equals the inverse tangent function of 8/5. So now then I use my calculator, still in degrees. And I'm going to find that theta is approximately, because I'm rounding, inverse tangent of 8/5, 57.995 degrees. And there you have it, how to use inverse trigonometry to solve for the missing angle in a right triangle. You can also do the same for sine, same process with an inverse sine. Good luck, and let me know if you need any help.